Hi, Pre-Calc. For those of you who don't know me, my name is Mrs. Peterson. We are going to be doing kind of a review today. We're going to be writing equations of lines. I've got the checklist on the screen. What I expect you to do when we do these videos is to have your notebook open, have one pencil and one pen ready to go. Your pen is to check answers, and make sure your cell phone is either off or on airplane mode or do not disturb, and then make sure you are watching with headphones in so that you are fully engaged, and lastly make sure that you are in full screen mode. So I don't know how many of you like to go skiing, but ski slopes and slopes of lines are very much analogous. And a little secret is that Calc, especially Calc 1, is actually all about slope. So we're going to spend quite a bit of time talking about slope today. When you go skiing, you've got different levels based on different colors, right? And you can see mathematically that the steeper the line, the larger the magnitude of the slope, okay? So, for example, a line with slope -5 is going to be a lot steeper than a slope with line -1/5. So let's write this down as our first note. So slope measures the steepness of a line. In other words, how fast are we going down that slope, right? And this is in general, how fast is our function changing? So let's write the definition. The slope, m, of a non-vertical line through 2 points, and we'll call them x1, y1, and x2, y2, is defined as rise over run, right? So it is your change in your vertical position. We typically denote that as y2 minus y1 over your run. So your change in your horizontal position, x2 minus x1, okay? And this is true as long as, again, this is a non-vertical line, so as long as x2 and x1 are different from each other. Why do we use the letter m? For slope, we actually are not completely sure. We think it comes from the French word monter, meaning to rise. But mathematicians, or especially historical mathematicians, are a bit stumped as to where that M came from. But we do think it stems from this French word meaning to rise, okay? So in general, another way to think about slope, you don't need to write this down, but just going to keep in mind that it measures how fast the height of your function, in other words, the y values, are changing, okay? So again, very analogous to a ski slope. Now in calculus, we typically use that function notation of f of x as opposed to y. So instead of like y2 minus y1, you'll often see it written, please write this down, as f of x2, right? So what do I get for y when I plug in x2 minus f of x1 all over x2 minus x1. So this is how you'll typically see it written in calculus. All right, I'm going to force a pause on your screen. Can you please copy these 4 lines in your notes? So we're back. So here are 4 possibilities of a line slope. If our line is increasing, then our slope, m, is positive, which we usually denote as greater than 0. If my line is decreasing, then slope is negative or less than 0. For horizontal lines, again, think about your ski slope. You are not going to be moving, right? Your slope is equal to 0. And then for vertical lines, your slope does not exist. In calculus, we denote that as d and e, does not exist. So these are different, right? A 0 slope versus an undefined slope. One way that you can kind of sometimes, hopefully, remember is 0 over a number is okay, but a number over 0 is a no, okay? So this would be an undefined number if you have 0 in the denominator. 0 in the numerator is just equal to 0, assuming, again, the denominator is different from 0. So I said Calc 1 was all about slope, or how fast certain things change with respect to time, right? Anytime you see a rate, we are talking about what's called differential calculus, and a rate is all about slope. In Calc, we learn to think about slope occurring at a single point, as opposed to slope going through 2 points, okay? Now, the most common form of equation of a line that we use is point-slope form, and this actually stems directly from the definition of slope. But point-slope form of a line, let's just put it in your notes to review here. It is y minus y1 equals m times x minus x1, okay? So x is your independent variable, y is your dependent variable, x1, y1 is any point on that line, and m is, of course, your slope. So let's read example 1 together. You don't need to write anything down yet. It says life expectancies are the average lengths of life for people in various groups. For example, the life expectancy of a person born in 1987, which would be me, is 74.77 years. Life expectancy of a person born in the U.S. in 2000 is 76.9 years. Life expectancy is predicted on the basis of many factors. Considering past data on life expectancies, what would you predict the life expectancy of someone born this year? And we're going to say this year is 2021, okay? 2021 to be. And we're also going to assume a linear growth pattern here, right? So let's write this down. We first want 2 points. So what I'm going to let x be my year, and y is going to be my life expectancy. Okay, so 1 point I would have is 1987, comma 74.77, and a second point I would have is 2000, comma 76.9. Okay, so now that I've got 2 points, I can certainly create my slope, and then I can also put this in point slope form. Okay, so let's write our slopes. Our change in y, I'm going to go 76.9 minus 74.77 all over 2000 minus 1987, right? Change in y over change in x. Now, it doesn't matter which one you let be y1 or y2, as long as you keep that same order when you do x1 and x2. So since I went purple minus green in the numerator, you just need to make sure I do that same order, purple minus green in the denominator. I could have done green minus purple, as long as I would have kept that pattern. All right, so let's go ahead and grab our calculators and simplify this. So I'm getting 0.164 approximately for my slope, which I'm going to call m. If there are no directions on rounding, please always give 3 decimal places, because that's what you'll need to do on the AP Calculus exam. So now that I've got m and I've got 2 points, I can write an equation of a line, right? It doesn't matter which point you use. I'll go ahead and use the green point. So I've got y minus y1 equals m times x minus x1 for my formula, right? So I'm going to go y minus, now grab the y1 value, 74.77, equals, for m we got 0.164 times the quantity x minus, and then here's my x1, 1987. So there's a line that will give me my life expectancy y for any year x. Now if I wanted, I could solve this for y right now, right? Now let's go ahead and plug in 2021 and solve for y there. So I'm going to let you finish off the problem again. Plug 2021 in for x, solve for y, hit continue when you're ready to see the answer. All right, I got about 80 years old, so life expectancy 80.346. All right, force another pause on your screen. Can you just copy the summary of equations of lines that I have here? So we're back, and I do want to kind of highlight here, this one is really, really important. This is the one we use the most in calculus. Now, sometimes the question will ask you to get it into slope-intercept form, but you can use point-slope form, right? And then just solve for y to get it into slope-intercept form. All right, and force a pause on your screen. I'd like for you to try example 2 on your own, and then hit continue when you're ready to check your answer. Make sure you grab a second color when you're ready to check your answer. My hint for the first one is solve for y, so get y by itself. In other words, get it in slope-intercept form. All right, answers are on the screen. Just put a little check if you got it right with your pen. If you got it wrong, correct it. Do keep in mind that for part B, that line is a horizontal line going through the y-axis at 2, so slope is 0. If it were slope undefined, remember that would be x equals a number. It would go through the x-axis. So slope there is 0, y-intercept is 2. So let's review parallel and perpendicular lines real quick. On the screen I have a line that has a rise of positive 2 and a run of 1. Okay, so this has a slope of 2 over 1, in other words, 2. Now if I create a parallel line, notice that it has the same slope, right, of a rise of 2, a run of 1, so another slope of 2. So parallel lines will have the same slopes, right? Let's write that. Now if I draw a perpendicular line, hopefully you can see these two are perpendicular. Notice that this time I went down 1 to the right 2. So my original had a slope of 2 over 1. My perpendicular has the negative reciprocal of that, which is negative 1 over 2. So perpendicular lines, their slopes are negative reciprocals of each other. In other words, flip and change the sign. All right, example 3, it says write an equation for the line passing through negative 2, 5 and parallel to this line, okay? Then write an equation for the line passing through the same point but perpendicular to the line above. All right, so first, I'm almost there because remember it doesn't say what form the line needs to be in, so easiest one is going to be point slope form because I have a point, right? And I can find the slope pretty easily because it's going to be the same as the slope of this line. So let's go ahead and solve this for y to figure out the slope. So I would have 3y, I need to subtract 6x minus 1. So I can tell if I divide both sides by 3 that my slope is going to be negative 6 divided by 3, which is going to be negative 2, right? So for my parallel line passing through the point negative 2, 5, remember that here's my point slope form, y minus y1 equals m times x minus x1. So I've got y minus, what's y1? 5 equals, now what am I going to plug in for m? Negative 2 times the quantity x minus, and what is x1? Also negative 2, right? But x minus negative 2 is the same as x plus 2, right? So there is my parallel line. Now if I want to make it perpendicular, all I've got to change is what? All I've got to change is the slope. So I'm still going to have y minus 5. Now instead of negative 2, I'll have positive 1/2 and keep your x plus 2. All right, and you can always check on Desmos, right? Here's the original graph that was given. Here's the point we want to go through. Here is the first line we got, which is indeed parallel, also going through that point. Here's the second line we got, which is indeed perpendicular, also going through that point. All right, friends, that is all we have for today. What I'd like for you to do is write one summarizing sentence from the lesson today, and I will see you all next time.